give me what is, okay, rather what you can do is put this as second. Number one, give me the E naught cell. What will be the E naught cell? Okay. And third, you are going to give me the Nernst equation. Okay. So now you have to solve this question. Just send it to me. When you have calculated these things, then we'll move to the next topic. Okay, Nawal?
Yes, sir.
Okay. Let me know if you get stuck or something. Yes, Rifat, correct. Very good. Yes, Nawal, very good.
Sir, with the PT,
Yes, Rifat.
with the PT, what are we supposed to do?
I cannot hear you. Can you speak properly, Rifat? थोड़ा जोर से बोलिए.
With the PT, what are we supposed to do?
Oh, PT. PT is
Yes.
just a electrode where you. It is an inert electrode. It does not react. Okay. It
So
is
we
just
can
providing a
ignore it.
surface. Sorry.
So we can ignore it in the cell reaction.
Yeah. Obviously, yeah. You can ignore it in the cell reaction. It is just providing a surface for this ion to gas. See, it is directly going from ion to gas now. So it is just providing a surface for that reaction. Yes. I think I will give you a note regarding inert electrode. I will not give you guys about that now. I think so. Yeah. Nawal, can you proceed further on? Calculate the value of log of product upon reactant, concentration of product upon reactant.
Yes, sir.
हाँ ठीक है, आप आगे फिर प्रोसीड कीजिए. हाँ सही है. Correct. Fifth. Your answer is correct. You can proceed further for the Nernst equation and then write the Nernst equation. Hanifa, what about you? Are you getting stuck somewhere?
I'm doing it, sir.
You're doing it? Okay. Hanifa, please send me if you have calculated the E naught cell. Please send me if you have calculated the E naught cell. Yes, very good, Hanifa. Correct. And yeah, I think that is correct now. Okay, we will see how I'll solve this question and we'll see. Yeah. Yes, Hanifa, correct. Can you proceed further on? Calculate the complete EMF of the cell. Can you do the log part also, Hanifa? Please try it. Rifat, what happened? आपने आंसर नहीं भेजा अभी तक?
Yes, sir, I'm sending it.
Okay. Okay. So for E naught of the cell, this will be equal to E naught of oxidation plus E naught of reduction. So here we see that oxidation of zinc is happening, but we have been given the value of reduction. So we'll just change it, switch the value and make it positive 0.76 plus, again, we have got the reduction, but again, we know that hydrogen is 0. So hydrogen 0, this will be what? Plus 0.76. This will be my E naught cell. Now moving on to anode and cathode reactions. For this, we may write first of all the anode reaction. The reaction at anode, which is zinc, is giving me zinc 2 plus 2 electron. In cathode, we have H plus ion, which is reacting with 1 electron. We have H plus ion, which is reacting with 1 electron and giving half mole of H2. So in order to balance the number of electron, we can multiply 2 here. We can multiply 2 here, 2 here, and 2 here. And this will result in the cancelling of the electrons. And we can also cancel this part. So we'll be getting zinc plus 2H plus ion gives zinc 2 positive plus H2 gas plus H2 gas. Okay. Now further on, we have the Nernst equation. In Nernst equation, we write EMF of the cell. The E cell is equal to E naught of cell minus 0.059 divided by, we are using 2 electrons, into log of. Now here in the product side, we have the hydrogen also. So write pressure of hydrogen into, we have zinc 2 plus. So Zn2 plus will be there, divided by the concentration of H plus ion squared. Now, since the hydrogen is only 1 bar, so we can replace that value and we'll calculate the log part first. So log of pressure of H2 into zinc 2 positive divided by the concentration of H plus square. This will give me 1 into concentration of zinc is 0.001, 0.001 divided by H plus concentration is how much? 0.01, 0.01 squared. So this will be equal to, if you see here, 0. Or rather I should write 10 to the power minus 3, and this will be 10 to the power minus 4. This will give me 10. So we have to basically calculate what is the value of log 10. So log 10 is equal to 1. We can again write the EMF of cell as E cell is equal to E naught cell is how much? 0.76 volts minus 0.059 divided by 2 and log of 10. Log of 10 is equal to 1. We can just write this is equal to 0.76 minus 0.03 volts. It will be equal to 0.73 volts. Okay. So that's the answer. I hope you guys got the similar answer. Yeah, correct. So here, very good. Okay. Now write the topic. Electrochemical cell and Gibbs free energy. Electrochemical cell and Gibbs free energy. Okay. Now, if we talk about the Gibbs free energy, that means now we are talking when there is a spontaneous reaction, how much energy is being released. Okay, when there is a spontaneous reaction, then how much energy is being released. What is the relationship generally? What we are talking, what is the relationship between the electricity that we are taking out of the cell, and the energy? So we have to have some relationship between electricity and energy. Okay, so we have to have some relationship between electricity and energy. Okay, now if you talk about the work, right, work done is what? That is the useful energy that we can get, right? Work also has the same unit as energy, that is of joules. So we can say that if we talk about the work that we can take off, that is equal to whatever charge is present times the potential. You have learned about this, yes or no? Please tell me. W is equal to Q into V.
Yes.
Physics में पढ़ा होगा आप लोगों ने, yes or no?
Yes, sir.
Right? Okay, fine. So I think this will be easy for me then. Okay. Now, if you're talking about a cell, then we can write this as Q into the E naught cell. Yes or no? Whatever energy, whatever electricity the cell is giving me. Make sense till here? Yes or no? Please tell me, guys.
Yes, sir.
Okay, fine. Now, the Q is what? Q is the charge. Q is the charge. And when we write an equation like this, for example, I'm writing something like this, Zn2 sorry, rather it should be Zn plus copper 2 plus is giving me Zn2 plus copper. Now here there is a transfer, or here we can say there is a movement of 2 electrons. Right? We say there is 2 electrons, but we know that, I mean, there will not be 2 electrons. In this reaction, it is what 1 mole of zinc react with 1 mole of copper 2 plus to give me 1 mole of zinc 2 plus and 1 mole of copper. So obviously this 2 electron is rather 2 moles of electron. Okay, so whenever we write the equation is read as 1 mole of zinc reacts with 1 mole of copper 2 plus to gives 1 mole of zinc 2 plus and 1 mole of copper. So obviously if one zinc is giving 2 electrons, that means this whole reaction, we can say that there is a transfer of, or there is a traveling of 2 electrons from zinc to copper, 2 moles of electron. So whatever charge we are going to write, it is what it should be in what it should be. We should take into consideration that we are moving 1 mole of charge with each reaction. So here, if I talk about the charge on 1 electron, this will be equal to 1.6 into 10 to the power minus 19 coulomb. A charge on the charge on 1 mole of electron. This is equal to how much? 1.6 into 10 to the power minus 19 into 6.022 into 10 to the power 23, right? Because this has 1 mole. This is 1 mole. If you multiply both of these numbers, you will get the answer as 96500 approximately coulomb. So what is 96500? This is a Faraday's constant. This is also known as 1 Faraday or 1F, and this is aka Faraday's constant. So when 1 mole of electron is traveling, it is giving me how much coulomb of charges? It is giving me 1 Faraday charges, or we can say 96500 coulomb. Okay. Now we can say for n moles of electron, the Q will be equal to n Faraday, because for 1 mole of electron, it is giving me 1 Faraday. If we have 2 moles, then it will give me 2 Faraday. If we have 3 moles, it will give me 3 Faraday. 4 moles, 4 Faraday, and n moles will give me n Faraday of charge. Now you can see we have an equation which says the work done will be equal to the number of moles into Faraday. Q into V था, आपको अगर याद हो तो Q into E naught cell था. And in this particular cell reaction, we are using n number of electrons which have F 1 Faraday of charge into E naught cell. Got it, guys? Let's know, please tell me. This equation, work is equal to NF into E naught cell. Okay. Next thing is that, now please listen very carefully. Please listen very carefully. The cell is doing this much work. सही है? Everyone agree? Please listen carefully. ठीक है? ध्यान से सुनिएगा इस स्टेटमेंट को. ये सही है ना? The cell is doing this much work. Yes or no? Please tell me. ठीक है. If someone is doing work, then it will be giving up electricity. It will be giving out electricity. So the human who is present, they will see that the change in, अच्छा, cell आपका काम कर रहा है. Cell is doing some work. Okay, cell is doing some work. Then the initial and there is final. ठीक है? Initial में मान लीजिए आपके पास 10 जूल था सेल के पास. सेल ने काम किया, सेल के पास अब बचे हैं 5 जूल. Okay, now final minus initial will be equal to 5 minus 10, that is equal to minus 5 joules. Yes or no? Please tell me, guys.
Yes.
ठीक है. अब यहाँ पे देखिए, सेल ने काम कितना किया? Work done by cell is equal to how much? 5 joules. And change in energy is equal to how much? Change कितने का हो रहा है? बताइए.
Minus.
दिख रहा है आप लोगों को? हनीफा एंड नवाल, please tell me. Can you see that?
Yes, sir.
Work done is 5 joule. And the change in energy is how much? Minus 5 joules. So I can write the equation which tells me work done, or rather we can say the delta G, whatever we are having, that is equal to the negative of work done. Clear as a question? Please tell me, guys.
Yes, sir.
No problem? No problem, na? Okay, fine. Now let us move on and write some statements. Okay, please write. In the case of electrochemical cell, Gibbs free energy is related to work done by the cell. Right. change in delta G, sorry, change in Gibbs free energy, delta G तो change ही होता है, change in free energy लिख दीजिए, free energy is equal to work done by cell. Okay. And we have also shown that delta G is equal to minus of W. Delta G is equal to minus of W. Since work is equal to the charge into potential difference, and potential difference here it is equal to E naught of cell. If you are taking the standard condition on, आप सीधा यहाँ पे E cell लिख दीजिए, छोड़ दीजिए, ठीक है, just write E cell, general case ले रहे हैं यहाँ पे. Now we have to calculate about Q. You will write Q in bracket charge is related to the number of electrons used in cell reaction. Right, charge on one electron is equal to 1.6 into 10 to the power minus 19 coulomb. Sorry, coulomb. Charge on 1 mole of electron is equal to 1.6 into 10 to the power minus 19 into 6.022 into 10 to the power 23. This will give me approximately 96500 coulomb. So this whole thing is known as 1F, which is also known as 1 Faraday's constant. Right, for n moles, Q will be equal to n Faradays. That is why work will be equal to Q into E naught, Q into E cell, which will be equal to N F E cell. This is what? Work. Okay, this is work. And we can write delta G will be equal to, we can just put a minus sign of W. And what is W? W is equal to minus NF E cell. Okay. Now you will write in standard condition. In standard condition, the standard Gibbs free energy will be equal to minus NF E naught of cell. NF E naught of cell. Write some remarks. Write number 1 point. Galvanic cell will work if E cell is positive. If E cell is positive. Because because when E cell is positive, delta G is negative. Second point, maximum work done by cell is equal to delta G naught. Okay, so in the standard condition, that is the maximum work done by a cell. लिख लीजिएगा तो बताइएगा. Let me know if you guys are done. Done? Okay. Write this question. I will discuss this question, okay? Done, guys? Yes or no? Please tell me. सवाल लिखिए. So in this question, please see here, you guys have not been asked about the E cell. So you have been asked only about the E naught and G naught. Okay. So no need to write the Nernst equation. You can just calculate first of all the E naught of cell. Can you guys calculate the E naught of cell? Tell me, Hanifa, Nawal, Rifat.
Yes, sir.
Yeah. Okay. Calculate the E naught of the cell and send it to me. Na? Same फंडा है, ठीक है, कोई डिफरेंस नहीं है. You just need to do E naught oxidation and E naught plus E naught reduction. E naught oxidation of the anode and reduction of, okay, fine. Got from the wall. Let me see. Very good, Nawal. Correct. Not saying. Okay, guys, please look here. E naught of oxidation plus E naught of reduction. So in oxidation of zinc is happening. So this will be plus 0.76. Reduction. This is reduction. So this is 0.80. This will give me 1.56 volts. Okay. Then you have to calculate the delta G naught. Delta G naught is going to be minus NF E naught of cell. NF E naught of cell. Okay. So right here, what is the number of electron used? So number of electron here is used, that is 2 electrons. Okay, because we have zinc, you can see 2 positive. Yeah, 2 electrons into Faraday's constant is 96500 into E naught of cell is 1.56, and you will have a negative sign here, right? Minus NF E naught cell. You can just multiply these things and tell me the answer. So this will be equal to T0 . You'll get this answer in joules, okay? So you'll have 301080 joules. So you can write it as 301.08 kilojoules. Okay. So the delta G naughts, these are very easy questions. Okay, you don't have to worry much about these questions. काफी आसान होता है. And also it is easier than the Nernst equation. Even though Nernst equation is very famous, if you get the question in which they are asking about the delta G naught, be happy. Okay, that is going to be an easy question.
Sir, shouldn't it be minus?
हमने माइनस नहीं लगाया क्या? नहीं, माइनस होगा. My bad, हम भूल गए. नेक्स्ट आप ये सवाल कीजिए. So what they are basically asking is, see, you have to refer to the table 3.1. Okay, so in your NCERT textbook, you see they're asking that if you have these are in reactant, Fe3 plus and iodine negative, if you have these in the reactant, then will the reaction take place? So what is the reaction that can take place? Fe3 plus iodine negative. This is going to give you what it is. Fe3 will be getting reduced to Fe, and iodine negative will be getting oxidized to I2. Okay, so sorry, I2. So basically what they are asking is Fe3 का reduction होना चाहिए and iodine negative का oxidation. So is this possible? Yes or no? So you have to compare. ठीक है, पहले आप सवाल को लिखिए इसको and then tell me what is the E naught of Fe3 plus 2 to Fe कितना है and E naught of iodine negative to I2. ये दोनों देख के बताइए. नहीं मिल रहा है क्या हम लोगों को? अरे हमने कब कराया था आप लोगों को? I have pasted that table if I remember correctly someday. नहीं
0.7
जी, यहाँ पे बताइए Fe3+ का कितना है?
0.77
पॉजिटिव में या नेगेटिव में है?
पॉजिटिव
Fe3+ to Fe देखिए ठीक से Fe3+ to Fe
नेगेटिव
ओके ओके फाइन. सो एक्चुअली Fe3+ का आपको Fe3+ से आपको Fe2+ तक का दिया हुआ, राइट? आई थिंक दिस इज गिवन टू यू गाइस, करेक्ट?
यस सर
हाँ, दिस इज नेगेटिव ना, ये नेगेटिव होगा. हाउ मच इज दिस? नेगेटिव सर, ये पॉजिटिव होगा. दिस विल बी 0. ओके, दिस इज 0.77 and I minus से I2, I minus से I2, this will be minus 0.54, correct? Yes or no?
यस सर
The opposite दिया हुआ है ना इसका, I2 नेगेटिव का इलेक्ट्रॉन, so this will be minus 0.54. ठीक है, तो वो यहाँ पे आपके पास what will be the E naught of cell? You have a reaction like this: Fe3 positive plus I negative, giving me Fe2 plus half I2. ठीक है, सो Fe3 पॉजिटिव से Fe2 पॉजिटिव में हमको मिल रहा है कितना? 0.77 volts of energy. And iodine negative to iodine, this is taking how much energy? Minus 0.54. तो आपके पास जो E naught cell होगा, that will be equal to how much? 0.77 plus minus 0.54. This value will be what? Positive, na? 7 minus 0.77 minus 0.54. साथ में 0.23 volts. So if E naught cell is possible, sorry, E naught cell is positive, delta G will be equal to what? Negative. You can say the reaction is possible. Got it?
यस
ठीक है, तो सिमिलरली आप लोग इसी तरह से रिएक्शन लिखिए Ag plus and Cu का क्या रिएक्शन होगा, and then you further get the E naught cell and then comment on the delta G, whether the delta G naught will be positive or negative. If it is negative, then it is spontaneous. If it is positive, then it is not spontaneous. Next reaction you have is Ag positive plus copper will give you 2Ag plus copper 2 plus. So Ag plus to Ag will give how much? 0.80 volts, and this is going to require energy, right? Copper 2 positive. Yeah. This will be what? Minus 0.79. Yeah, minus 0.34 होगा शायद. So you can write E naught of cell is equal to 0.80 plus minus of 0.34. कितना आ जाएगा ये आंसर? 0.46. So this is also delta G naught will be negative because E naught cell is positive. So possible. Okay, as you can see, it is very similar and it is using the same concept of what we learned in the feasibility of reaction through electrochemical series. But here we are using the data. So if you have been given the data, then it is also well and good. What you can do, then you have to show actually that E naught cell is positive. That is why delta G naught will be negative. Next आपका क्या है? Fe3 positive and Br negative. हाँ बताइए.
Copper can't we use minus 0.54?
क्या?
Copper, we can also use 0.5 minus 0.54.
Minus 0.54. एक second.
Sorry, minus 0.52.
Minus 0.52.
Yes.
If they will give you that, then you are going to use that. Generally आपका copper 2 plus से reaction होता है. Okay. तो उस वजह से आप वो भी use कर सकते हैं. There is no issue in that. But I think the answer will be same, right?
Yes.
So they will actually give you, for example, यहाँ पे तो आपको बोल दिया कि आप वहां से टेबल से देख लीजिए, लेकिन वो generally आपको देंगे E naught copper 2 plus to copper is equal to 0.34. इसका उल्टा हो रहा है इस वजह से minus 0.34. So again, we have Fe3 positive. So Fe3 positive to will go to Fe2 positive only. So we have Fe3 positive plus Br negative gives me Fe2 positive plus half Br2. So Fe3 positive to Fe2 positive, it is going to give me how much? The 0.77 था ना? Plus में. And Br negative to half Br2. This will be how much? Minus 1.09. शायद. हाँ.
Yes.
यहाँ पे साफ दिख रहा होगा that E naught cell will be equal to 0.77 minus 1.09. This will be obviously whatever the values, it is going to be negative. Delta G will be positive. Hence, this is not feasible or not possible. Okay. You can. I will give the further. The next question as assignment. We can move on to the next topic. Okay. Please write the next topic. Nernst equation and equilibrium constant. Write the next topic. Nernst equation. हनीफा एंड नवाल, आप लोग को समझ में आया ना ये कैसे करना है?
Yes, sir. Yes.
Okay. Okay, right. Next equation. And equilibrium constant. Okay. So what happens in equilibrium? Nothing happens at equilibrium. Okay. So जब भी ऐसे equilibrium में क्या होता है? Equilibrium में कुछ नहीं होता. Nothing happens at equilibrium. And if nothing is happening at equilibrium, that means my cell is not working. My cell reaction is not working. Why? Because this reaction, for example, if I have the zinc and copper cell, this reaction has achieved equilibrium. Zinc, please don't write anything, plus copper 2 positive, giving me zinc 2 positive and copper. This is whole reaction has become reversible in nature. That is why there is no electron flow. That is why there is no electricity also. At equilibrium, nothing happens. Okay. At equilibrium, what happens? Nothing happens at equilibrium. So right here, since when current becomes 0, then it is said that equilibrium is achieved. Equilibrium is achieved, and the E cell is equal to 0. E naught cell will never be 0 because E naught cell is standard condition में हम लोग measure करते हैं. So E naught cell तो 0 नहीं होगा. E cell क्या हो जाएगा? 0 हो जाएगा. उस वक्त पे हमारा जो cell है, it will not draw any current. So for example, if I have something like this, for example, we have a cell in which this reaction is happening. Zinc plus copper 2 positive is in equilibrium with zinc 2 positive plus copper. So we'll write that E cell will be equal to E naught cell minus, if you're doing this at room temperature, 0.059 divided by n log of zinc 2 positive upon copper 2 positive. Okay, upon copper 2 positive. Now, since both of these zinc 2 positive and copper 2 positive will have achieved the equilibrium concentration. So these are the concentration of zinc and copper at equilibrium. This whole thing will be known as what? This whole thing will be known as Kc. If you remember, if you have achieved equilibrium, then the reaction quotient becomes what? Equilibrium constant at equilibrium. Okay, and this Q is log Q only, which is what? Which is log Q. That means reaction quotient A, product upon reactant. Okay, so what is going to happen next? E cell is equal to 0 because equilibrium is equal to E naught of cell minus 0.059 upon n and log of the equilibrium constant. Equilibrium constant is the concentration of zinc upon copper at equilibrium. Okay, product upon reactant at equilibrium. Now we will write further on. E naught cell we can write as E naught cell is equal to, this will go here, it will become positive, so 0.059 upon n log of Kc. Okay, so this is the relationship between E naught of cell and the equilibrium constant. So please write this down. Nernst equation and equilibrium constant. Please remember, E cell is equal to 0 EMF, not E naught. Okay. Equilibrium constant Kc is related to what? E naught of cell. Standard condition E naught. Because at equilibrium, the E cell EMF of the cell becomes 0. Because cell is not working at that time, right? Because at equilibrium, nothing happens actually. Okay. Done ना guys? लिख लिया आप लोगों ने? लिख लिया आप लोगों ने? ठीक है. चलिए सवाल करते हैं. So see, what they are asking, calculate the equilibrium constant of the reaction. This reaction has been given, and then you have to calculate the equilibrium constant. So whenever you have been given something like this, we know that the E naught cell is equal to 0.059 upon the number of electrons that are being used in this particular reaction, log of Kc, right? This is my equilibrium constant. So whenever you have been asked about equilibrium constant, you will write this reaction. Now, can you tell me with the given data, can you calculate the E naught cell? Yes or no? Please tell me, guys. कर सकते calculate, है ना? Also, you can see the number of electrons. बताइए कितने number of electron use हो रहा है यहाँ पे? 2. Very good. I hope you guys can now see in the reaction, even when the number of electron is not given, that how many electrons are being used. Okay. Now, just calculate E naught cell first of all. आप भी कीजिए, हम भी कर रहे हैं. So here we can see that Fe is getting oxidized. So I will take plus 0.44 plus. Then we have cadmium reduction, which is equal to minus 0.40. This will be equal to 0.04. So the E naught of cell is equal to 0.04. All of you are getting the same answer? Yes or no? Please tell me.
Yes. Yes.
Yes. Okay. Fine. Next thing is that we are going to put E naught cell into that equation. Okay. So we can also write n is equal to 2 in this particular reaction, and E naught cell, that is 0.04, will be equal to 0.059 upon 2 and log of Kc. Log of Kc. Okay. Now what we can write, log Kc is equal to 2 into 0.04 divided by 0.059. तो यहाँ पे इसको कर लेते हैं 0.08 divided by, अब 0.059 को you can approximate this to 0.06. ठीक है, बहुत ज्यादा चेंज नहीं आने वाला आंसर. So this will be equal to how much? 8/6, यानी कि 4/3. सही है? Yes or no? Tell me. Correct है guys? Okay. This is what log Kc. Log Kc is equal to 4/3. Log Kc is equal to 4/3. यानी कि what they are saying, you have to calculate Kc. तो Kc क्या होगा? 10 to the power 4/3 is equal to how much? सही है? Yes or no guys? Please tell me. This is how we are going to get the Kc, ना? अरे हाँ ना तो बोलिए, क्या हो गया? सही है, ठीक है. तो यहाँ पे देखिए आप, Kc is equal to 10 to the power 4/3. I can write this as 10 to the power 4, ठीक है, minus into 10 to the power minus 3. लिख सकते हैं?
Yes, sir.
-3 लिख सकते हैं? नहीं, आई डोंट थिंक सो। -3 लिख सकते हैं? हाँ, -3 लिख सकते हैं। ठीक है, लिख सकते हैं ना कि नहीं लिख सकते हैं?
Yes, sir.
लिख सकते हैं ना,
Yes.
है ना? क्योंकि ये तो क्या होगा, 1/3 होता ऐसे तो। और हाँ ठीक है, नहीं कंफ्यूज हो जा रहा है। ठीक है, तो ये अपना कितना हो जाएगा, ये 10⁻1 हो जाएगा, है ना? ऐसे भी हो जाएगा, हाँ 10⁻1 हो जाएगा ना, 10 हो
Yes.
जाएगा, Kc इज इक्वल टू 10 आ जाएगा। सही किया हमने? नहीं सही किया लग रहा है हमको, तो सही नहीं लग रहा है हमको। 1 सेकंड, थोड़ा देर 1 सेकंड रुक जाइए सर आप लोग। 10⁻4/3, नहीं नहीं नहीं, ऐसा नहीं लिख सकते। वेट अ सेकंड, ऐसे नहीं लिख सकते। ऐसे अगर रहता ना 10 × 4, नहीं, I think I cannot, can we do that? I don't think so. No, we cannot do that, sorry, my bad. Okay, so यहाँ पे हम लोग क्या कर सकते हैं, 4/3 को डिवाइड कर लेते हैं। So 1 सा 3, 1.09, so this will be equal to how much again, 1.999 कुछ आ जाएगा, राइट? So 10⁻1.999। आप बोलिएगा सर आपने तो और कॉम्प्लेक्स कर दिया, ऐसे कैसे कैलकुलेट कर ले? दिस विल बी द आंसर ना, 4/3 का।
Yes.
नहीं, अरे ये सर बोले जा रहे हैं आप लोग, हमने यहाँ पे गलती की है। 1.3333 होगा, ठीक है, 1.3333 होगा। ओके, अब इसमें हम लोग ऐसे कर सकते हैं, 10⁻0.3 इंटू 10⁻1, सही है? अब ठीक है, 10⁻0.3 इज इक्वल टू 2। कैसे पता हमको? बिकॉज आई नो दैट log 2 इज इक्वल टू व्हाट, 0.30। सो 10⁻0.3 विल बी इक्वल टू 2। ठीक है, इस वजह से 10⁻0.3 इज इक्वल टू 2 इंटू 10 विच इज इक्वल टू 20। सो केसी आपके पास कितना जाएगा, अप्रोक्सीमेटली 20 आप लोग लिख सकते हैं आंसर को। ओके, प्लीज राइट दिस डाउन। आई वाज डूइंग दैट रॉन्ग, 4 - 3 नहीं होगा, 4 - 3 हम क्यों लिख रहे थे, लेकिन अगर हमारे पास सब कुछ तो होता है ना, हम भूल ही गए इसको। वेट अ सेकंड, आप इसको नोट डाउन कीजिए। 10⁻4 - 3 इज इक्वल टू 10⁻4 इंटू 10⁻-3, ऐसे होता है ना भाई। ये होता है, ये होता है ना, हाँ ये होता है। और 4/3 का क्या होता है, 10⁻4/3। इसका ऐसे होता है कि 10⁻4/10⁻3, ऐसे लिख सकते हैं। नहीं, ऐसे भी नहीं लिख सकते हैं, ऐसे लिख सकते हैं क्या, पता नहीं, देखते हैं किसी का। ना ऐसे भी नहीं लिख सकते हैं, ये तो वही हो जाएगी, वैसी बात हो जाएगी। हाँ अच्छा, ऐसे को उस तरह से लिख सकते हैं। ओके ओके ओके, 10⁻4/10⁻3 को ऐसे लिख सकते हैं, 10⁻4 - 3, उल्टा नहीं हो सकता। ये हो सकता है, दोनों सेम चीज है। ओके, इसका और कोई दूसरा उपाय नहीं है। आई थिंक यू हैव टू डिवाइड इट एंड देन ओनली वी कैन कैलकुलेट। लिख लिया आप लोगों ने ये सब में?
Yes, sir.
चलिए अगला सवाल कीजिए। और ये रहा अगला सवाल। Okay. So in this question, you have now, okay, you have been given the Zn also and the delta G naught also. But again, like there is no use of delta equilibrium constant for the reaction. Yeah, actually there is no use of delta G naught. If you have been given the E naught, no, then there is no use of delta G naught. Yeah, there is no need of delta G naught. Here what you have been given. Calculate the equilibrium constant, only E naught somewhere. ठीक है, सेम चीज आप यहाँ पे कीजिएगा. फर्स्ट ऑफ ऑल कैलकुलेट द E naught of cell, which will be equal to कितना, याद हुआ कि नहीं आप लोगों को, जिंक और कॉपर का कितना होगा? What will be the E naught for zinc and copper cell? नहीं याद हुआ अभी तक, जल्दी बताइए. What will be the E naught? E naught oxidation plus E naught reduction. देखते कौन पहले बताता है. अरे बहुत टाइम लग रहा है आप लोगों को, तो सवाल लिख रहे हैं क्या अभी तक? What happened, guys? Hanifa, Nawal, Rifat, what is E naught of cell? यहाँ से निकाल लीजिए ना. Oh my God, प्रेशर में आ गया लगता है. Yes, Hanifa, tell me.
0.42.
आंसर आप चैट में लिखिए. हनीफा, आपकी आवाज ही नहीं पहुंचती है. यस, दूसरा कौन आंसर कर रहा था?
Sir, 1.1.
रिफत, आपकी भी आवाज नहीं आ रही है. चैट में लिखिए.
1.1. Sir.
हाँ, 1.1 याद कर लीजिए, जिंक एंड कॉपर का. ओके, जिंक एंड कॉपर का जो ई नॉट सेल होता है, दैट इज 1.1 वोल्ट. सो यू कैन राइट नाउ ई नॉट ऑफ सेल इज इक्वल टू 0.059 डिवाइड बाय द नंबर ऑफ इलेक्ट्रॉन्स. हाँ हनीफा, करेक्ट. into log of Kc. Okay, so now we can write also log of Kc is equal to n into E naught cell. n आपका कितना है यहाँ पे? 2 into 0.059. देखिए कितना आसान सवाल है. डिवाइड बाई नंबर ऑफ इलेक्ट्रॉन्स कितने हैं हमारे पास? 2 ही हैं. उसके बाद में कितना था? अरे कुछ गलती किया क्या मैं पिछले बार? सॉरी सॉरी गाइस, सॉरी. दिस विल बी 1.1 और नीचे आएगा 0.05. माय बैड. आप ही लोग कीजिए, अब तो हमसे गलती हो जा रहा है कुछ कुछ. यहाँ पे कैलकुलेट कीजिए. 2.2 अपॉन 0.06 कर लीजिए इसको. ये 1.1 अपॉन 0.03. और इससे आगे क्या होगा? इसको कर लीजिए 110 अपॉन 3. 3 इंटू 3 डिवाइड बाई 110. सो 3 3 9 एंड आई थिंक 30 कर देते हैं तो उसको 90 हो जाएगा. बच जाएगा आपके पास कितना यहाँ पे? 20. एंड 20 के बाद और इसमें ऐड कर देते हैं हम लोग 3 6 6 18 हो जाएगा. ये 2 बच जाएगा एंड देन पॉइंट लगा देंगे और 30.666 होगा. चलो, if you're getting the same thing. Sorry, 36.666 होगा. प्लस है यहाँ पे. तो Kc is equal to 10 to the power 36.66. This will be equal to 10 to the power 0.66 into 10 to the power 36. 10 to the power 0.66 किसके नजदीक हो जाएगा?
फोर और फाइव के
Log
बीच में
5.
कितना? 4.5. 10 to the power 10 to the power 0.66 कितना होगा? According to the log table.
0.7. Log 6. Log 5. sorry.
log 5 0.7 होता है, और तो थोड़ा बीच में 4.5 लिख सकते हैं इसको, है ना? तो अप्रोक्सीमेट कर लीजिए, 4 और 5 के बीच में, है ना? जस्ट बिटवीन 4 एंड 5. ठीक है. और दूसरी चीज देखिए, दूसरा ऑप्शन ये है कि लॉग टेबल सीखे. ठीक है. सो लॉग टेबल सीखने से अच्छा है कि आप थोड़ा सा अप्रोक्सीमेशन ही सीख लीजिए. आई थिंक दिस विल बी द आंसर. आई थिंक आई हैव नॉट गॉन रॉन्ग समवेयर. प्लीज एक बार आप लोग चेक कर लीजिए लेकिन. ओके. Done guys, Asana, please tell me. Yes, Hanifa, Nawal, done.
Yes, sir.
Right. Next. Standard hydrogen electrode. Is right. This has also been abbreviated as standard hydrogen electrode. Since it is impossible to determine the absolute EMF for single electrode, okay, EMF of single electrode, it is done by selecting a reference electrode. Selecting a reference electrode. Selecting a reference electrode whose standard electrode potential is assumed to be 0. Is assumed to be 0 what? 0 volts. ठीक है. देखिए, एक्चुअली whenever we are having electrode potential ना, तो किसी सिंगल का तो निकालना बहुत, like it is impossible, obviously मुश्किल है, it is impossible to get for single electrode potential because there is no device to measure that. There is no device to measure. Okay, so क्या कर सकते हैं? We have this one half cell here, the other half cell here, and then we are connecting it through a wire. Okay, then we are connected through a wire. यहाँ आपके मान लीजिए salt bridge है, and here we have the rods. Okay, and here we have some voltmeter. Now, how do we detect this? How do we detect how much voltage is there? Or if you can say that, for example, let us say we have some bulb here. And what do? We start putting resistance here. Start putting resistance. And let us say, for example, we started with zinc and copper cell. And we started giving it a resistance of, let us suppose how much? 0.5 volts. For 0.5 volt, if you are giving the resistance, then still the bulb is blinking. Okay, still the bulb is blinking. So we then did 0.6, bulb is blinking, 0.7, bulb is blinking, 8, 9, and then 0.8, 0.9, and then we did 1. Still 1 volt, the bulb is blinking. Then we did 1.1. And when we had a resistor of 1.1 volt, then what happened? This bulb stopped blinking. That means 1.1 volt of electricity was traveling in this particular cell. And when we put a resistor, that in that case, what happened? This bulb is not working right now. This bulb is not working right now. So this is how they measure the. This is how they measure the electrode. The E cell. Now we can only get the E cell. Okay, what we can get? We can only get the E cell. EMF of a particular cell. We can never get how much electricity is used for this particular half cell and how much electricity is being used from this particular half cell. So they said that, okay, fine, what we can do is we can take a standard reference thing. For example, we can start taking a reference electrode. For example, they took SHE, hydrogen electrode, as the reference electrode. And we will say that this reaction, H plus to H2, it is happening at 0 volts. Okay, it is happening at 0 volts. Now, then they start putting the other, here we have SHE, and here we have zinc. And when we have SHE and zinc, then the current that was flowing here, it was equal to 0.76. It was 0.76 volts. Okay. Now, since SHE, we have assumed it to be 0, all the electricity was flowing because of what? Because of the zinc. And that is how they have kept those numbers of different electrode potentials. By what? By taking the standard hydrogen electrode as 0. They have assumed the standard hydrogen electrode is what? It is equal to 0. So we have to learn about the standard hydrogen electrode. How does it look? Okay, so please write here. The reference electrode against which electrode potential of another half cell is calculated is the standard hydrogen electrode. Okay, standard hydrogen electrode. So how does the standard hydrogen electrode looks? Just a second, okay. I'm just looking for a better picture. If we have somewhere, then we can put it here. NCERT1 is quite simple and it's quite effective also. Just draw this. हमको ये समझ में आ रहा है कि आप लोगों में ना किसी को समझ में नहीं आया कि स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड का फंडा क्या है. Yes, रिफत आपको समझ में आया? यस रिफत,
Sir,
हाँ नहीं है,
not complete.
बनाइए, हाँ हाँ ठीक है, इसको बनाइए फिर हम डिस्कस करते हैं, ठीक है। एंड विद दिस इलेक्ट्रोकेमिकल सेल हो चुका है, ओके। सो मोर देन आई कैन से हाफ ऑफ द चैप्टर इज डन। नेक्स्ट क्लास में जो हम लोग पढ़ेंगे, नेक्स्ट क्लास में विल टॉक अबाउट द इलेक्ट्रोलाइटिक सेल। आई थिंक ओके फाइन। Hanifa, Nawal, and Rifat, tell me one thing. Can you take an extra class on next Friday?
Sir,
Give
my
me a thumbs
exams
up.
are starting from next week.
आपके एग्जाम स्टार्ट हो रहे हैं नवाल?
Yes, sir.
कब से?
2nd October.
2 अक्टूबर ना, तो आप 30 को आ जाइए, फ्राइडे इज 30।
Sir,
इसी
what
वजह से तो
time?
बुला रहे हैं। हाँ रिफत, टेल मी
What time?
व्हाट टाइम? सेम 4 to 6 कैसे, क्या ख्याल है गाइस? टेल मी,
Sir.
गिव मी अ थम्स अप। आवाज ही नहीं आ रही है आप लोगों की तो। इफ इट इज ओके, ओके रिफत की तरफ से हाँ है। नवाल, व्हाट अबाउट यू?
Yes, sir, I can try.
हाँ ठीक है, आज नहीं नहीं प्लीज आ जाइए, है ना। आपकी इलेक्ट्रोकेमिस्ट्री तो आ रहा है ना, 2 ही चैप्टर तो आ रहे हैं आपके नवाल, ठीक है।
No, sir.
सॉरी,
I have 5 chapters.
5 चैप्टर आ रहे हैं केमिस्ट्री में।
Yes, sir.
आप दमाम में है ना?
No, sir, I'm in Riyadh.
ओके, रियाद में यूनिट टेस्ट हो रहा है?
No, we have midterms.
कौन सा स्कूल है आपका?
New Middle East International School.
ओह यू हैव न्यू, ओके फाइन, ठीक है, सॉरी। व्हाट आर द चैप्टर्स?
Haloalkanes and haloalkenes, alcohol, phenol, ethers, biomolecules, solutions, electrochemistry.
तो बायोमोलिक्यूल्स आपका बचा रह जाएगा, इलेक्ट्रोकेमिस्ट्री का कुछ पार्ट बचा रह जाएगा। केमिस्ट्री का कब है?
I think it's on 13th.
14th?
13th.
13th?
Yes, sir.
अच्छा, तब तक तो इलेक्ट्रोकेमिस्ट्री भी हो जाएगा इंशाल्लाह, ठीक है। ऐसा मत कीजिएगा कि आप क्लास आना बंद कर दें, क्लास आते रहिएगा, एग्जाम चलने से क्या हुआ, ठीक है। मेन प्रिपरेशन तो बोर्ड का है ना। तो नेक्स्ट फ्राइडे
Yes.
30th अक्टूबर 4 to 6 PM के से, ठीक है, ओके फाइन। तो थोड़ा आप लोग माइक एडजस्ट कर लीजिए अपना, ठीक है, थोड़ा माइक एडजस्ट कर लीजिए। एंड नाउ यू गाइस टेल मी, आपके पास एक सेल है इतना, ऐसे दिस इज हाफ सेल, यस और नो, प्लीज टेल मी गाइस, हनीफा, नवाल एंड रिफत।
Yes, sir. Yes, sir.
हाफ सेल है ये, हाफ सेल है, दैट मींस द सेल इज नॉट कंप्लीट ना, करेक्ट?
Yes, sir.
Cell is not complete. So will electricity flow here? Will current flow?
No.
No, right? That means यहाँ पे अगर हम वोल्ट मीटर भी लगाएंगे तो it will give me just 0 volts. सही है?
Yes.
Correct? Okay. But if I have two half cells like this, with a salt bridge, now I can put a voltmeter, yes or no?
Yes.
अब यहाँ पे ये कुछ इलेक्ट्रिसिटी बताएगा हमें, right? It is giving some electricity. Now the question is, we have anode and we have cathode. So how much electricity, how much is coming from the anode and how much is coming from the cathode? ये तो पता लगाना, लेकिन it will be impossible, right? Yes or no? Please tell me, guys.
Yes.
है ना? It will be impossible to get what is the exact electricity that is coming from anode and what is the exact electricity that is coming from the cathode. ठीक है? So in this case, what we have to do, we have to take some electrode जिसका हम लोग जीरो मान लें. ठीक है? जिसका क्या करें हम लोग जीरो मान लें. तो यहाँ पे भी हमने क्या रख दिया? यहाँ पे we have taken it as this is standard hydrogen electrode और इसका कितना होता है? जीरो होता है. ठीक है? सही है? We have assumed this. Hanifa, Nawal and Rifat, tell me.
Yes. Yes, sir.
ठीक है? हम लोग ने जीरो क्यों लिया बताइए? Why did we take zero?
Because we don't.
What is it? हाँ, जोर से बोलिए रिफत.
Because we don't know the exact.
हाँ, we don't know the exact and we have to know exact in order to, नहीं तो फिर हमें क्या करना पड़ेगा, हमें सबका सेल मतलब बना के देखना पड़ेगा ये इसके साथ करेगा कि नहीं, ये इसके साथ करेगा कि नहीं. ठीक है? मतलब रिएक्ट करेगा नहीं या फिर इज दिस सेल पॉसिबल और नॉट, फिर हमको क्या करना पड़ेगा, बना के देखना पड़ेगा. कोई थ्योरेटिकल हमारे पास सिस्टम नहीं होगा. फॉर एग्जांपल यू हैव सीन दैट वी नाउ हैव अ थ्योरेटिकल सिस्टम. इफ यू नोट द ई नॉट ऑफ सेल्स, अब ये ई नॉट यहीं से आया है. ठीक है? अब यहाँ पे क्या किया इन्होंने, स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड में जीरो रखा. ठीक है? स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड में जीरो रखा और यहाँ पे इन्होंने डाल दिया जिंक. ठीक है? अब वोल्ट मीटर में देखा तो हमारे पास निकल के आया 0.76 वोल्ट्स. ठीक है? गॉट इट गाइस? यस और नो? प्लीज टेल मी.
Yes, sir. Yes.
अब यहाँ से इन्होंने बोला ओके दैट मींस वी कैन से दैट E नॉट ऑफ Zn टू Zn2 प्लस इज इक्वल टू 0.76 वोल्ट. यानी कि जब जिंक का ऑक्सीडेशन होता है तो हमको कितनी इलेक्ट्रिसिटी मिलती है? 0.76 वोल्ट्स. ठीक है? बट दिस इज विथ रेस्पेक्ट टू हाइड्रोजन. ठीक है? यानी कि जब हम लोग ये बोलते हैं ना that zinc and zinc 2 plus is giving me 0.76 volts of electricity, this is giving me this much electricity when it has been coupled with hydrogen electrode. ठीक है? और since hydrogen is zero तो हम लोग इसका बोल देते हैं कि ये zinc का ही potential है. लेकिन in reality it is what? It is respective. It is with respect to what? It is with respect to standard hydrogen electrode. वहीं पे हम लोगों ने देखा कि जब कॉपर रख रहे हैं यहाँ पे, when we are keeping copper here we have copper and here we have SHE. Okay, so I'm not making salt bridge and all. यहाँ पे हमने क्या देखा, यहाँ पे हमारे पास चला ही नहीं. It is not giving me any electricity. 0 volts. 0 volt जब मिला तब साइंटिस्ट ने सोचा ओके फाइन, दैट मींस कॉपर का ऑक्सीडेशन नहीं हो पा रहा हाइड्रोजन के प्रेजेंस में. दैट मींस कॉपर इज नॉट एबल टू रिड्यूस हाइड्रोजन. तो स्विच किया उन्होंने. यहाँ पे 0 वोल्ट था, अब इन्होंने क्या किया, स्विच कर दिया. यहाँ पे रख दिया SHE और यहाँ पे रख दिया कॉपर. अब क्या हो रहा है, हाइड्रोजन स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड में ऑक्सीडेशन हो रहा है, कॉपर में रिडक्शन हो रहा है. अब जब उन्होंने यहाँ पे चलाया, देन दे फाउंड आउट दैट इट इज गिविंग मी, they put a voltmeter and this voltmeter was giving me plus 0.34 volts. बात समझ में आई? तब इन्होंने बोला ओके फाइन, दैट मींस E नॉट ऑफ कॉपर 2 + 2 कॉपर, यानी कॉपर का रिडक्शन में कितना मिल रहा है हमको, 0.34 volts. Now you get an idea why the standard hydrogen electrode is being used and how it is being used. Yes or no? Please tell me.
Yes, sir.
है ना? पहली चीज है कि क्यों यूज कर रहे हैं, why यूज कर रहे हैं, बिकॉज E नॉट ऑफ हाफ सेल is impossible to measure. Exactly इसको measure करना, absolute electrode potential, it is impossible. एक चीज है ये why. Then how we are using it? क्या कर रहे हैं? We are making different cells. We are coupling different metal with standard hydrogen electrode. ठीक है? We are taking एक टाइम जिंक ले रहे हैं, कॉपर ले रहे हैं, फिर देख रहे हैं कि पॉजिटिव आ रहा है, जीरो आ रहा है. जहां भी पॉजिटिव आ रहा है तो वहां पे पॉजिटिव रखा, यहाँ पे बोल दिया कॉपर का रिडक्शन सही है. उसके बाद Ag का भी देखेंगे हाइड्रोजन के साथ, तो रिडक्शन हो रहा है ना? अगर हम लोग Ag को ऑक्सीडेशन वाले कंटेनर में रख देंगे, एनोड में रख देंगे, तो वहां पे रिएक्शन होगा ही नहीं एंड वहां पे हमारे पास इलेक्ट्रिसिटी मिलेगी ही नहीं. ठीक है? सो देन वी विल से दैट ओके फाइन, लेट अस स्विच दिस अप एंड लेट अस कीप द सिल्वर इन व्हाट, इन द कैथोड, एंड वहां पे फिर हम लोगों को मिल जाएगा प्लस 0.80 वोल्ट्स ऑफ इलेक्ट्रिसिटी. ठीक है? सो दिस इज हाउ वी आर यूजिंग इट. गॉट इट गाइस? ठीक है. आप यहाँ पे देखिए, समझ में आ गया ना? हनीफा, नवाल एंड रिफत, yes or no, please tell me.
Yes, sir.
ठीक है, okay.
Yes, sir.
Now you have to write some reactions because standard hydrogen electrode लिख दिया हमने. तो please write, when standard hydrogen electrode is at anode. अगर हम जैसे फॉर एग्जांपल कॉपर के केस में स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड कहाँ रहेगा? एनोड में रहेगा. तो क्या रिएक्शन होगा उस टाइम? we'll have H2 gas which is going to give me 2H plus 2 electron. और यहाँ पे इसको रिप्रेजेंट कैसे करते हैं हाफ सेल को? we represent it like this, platinum slash H2 gas slash H plus, यानी कि H2 is converting to H plus in the presence of platinum. कहाँ पे रिएक्शन हो रही है? platinum rod. If you see this particular, you can see here, this part is what? It is platinum. So this platinum is half in the acidic H plus ions and it is half inside this. This is tube. Okay, so it is inside tube also, which is connected to the wire, and it is also inside the solution. So this platinum is acting as an inert electrode. Okay, it is acting as an inert electrode. So reaction may take part, but it is providing a surface for the reaction. Now, what is going to happen when SHE is at cathode? Please write, when standard hydrogen electrode is at cathode, then 2H plus ulta ho jayega reaction, plus 2 electron is going to give me H2 gas. In this case, H plus is getting converted to H2 gas, and H2 gas वो pass हो रहा है किधर से? platinum में. सारा reaction कहाँ पे हो रहा है? platinum में हो रहा है. Okay, so this is how we represent it when it is a cathode. Write a note. Function of platinum electrode. What is the function of platinum electrode? Please write. Since platinum is inert electrode, sorry, right, ऐसे लिखिए, inert metal लिख दीजिए इसको, inert metal it does not take part in the reaction and only provides surface for the chemical reaction. ठीक है, please write this down.